Welcome to statistics. Statistics, actually, because we're doing the worst thing in the world. We're going to be doing this one page, and we're going to do this other page, and that's literally the entire day. Not really. I want to start with the actual homework assignment. Okay, I want to go through it. I want Newton to tell me the rights and wrongs. I want to kind of learn the system and see what they have. Okay, we'll go back to the workbook in a little bit, and that's fine. It's all copy paste, but I'd rather get it like clearly right or wrong and have instruction. Sound good? Okay, here we go. 3.3b. Here we go. And like I usually prep for this kind of thing, and no matter how many times I do this, it will not be enough. So we're just going to figure it out together. Let's make it a little bit bigger, just a tiny bit bigger. Control plus. Okay. So the main idea is that we're using the P and the C, just like we had last time, right? I'm going to ask you a question. When I have a C, is order important or not important? Not important, right? If you have a P, order is important. So far, so good, right? So we're going to use that in a way to get probabilities. All right. Two hospitals are sending doctors. The first hospital is sending 20 doctors. The other one's sending 30 doctors. Only 15 will make presentations, etc. Let's just pause. Is order important in this situation? Do I have to line up my doctors in an order? No. Like, and they're even telling you order's not important. See, isn't that kind of nice of them? They're telling us order's not important. Okay. So what's the probability of exactly 8 doctors from the first and 7 doctors from the second? And there you go. Okay. This is actually one of the better questions. So we're going to fill it in, and I'm so sorry for the font. It's going to be so tiny. But what I consider these two, I need to get some more paper. I need to get room. I need to draw on something. Hold on. You're going to give me a break for a second, right? What if is there white paper? Yeah, there's white paper. Let's side by side this for a second, okay? I need to kind of give you like a formula in a way. So I like to call this, I would say like the box method. Nah, there's got to be a better way to say that. Where's my markers? Guys, I want to draw on it. Does it have draw? It has colors but highlight. Ah. Okay, I like to call it the box method, kind of. Here, let me set this up, okay? This is what I call it. So this is one category. In this case, it'll be the first hospital. And this will be another category. I'm going to call it the second hospital. And then down here, I'm going to call it like the total of both hospitals. Okie dokie. And that's a time sign between them. Okay. You can see that it has a time sign right here. Is order important? No. And so I put a C for all of them. And this is where we're going to start to ask totals and selected for each one of them. So let's go first with totals. How many total are from the first hospital? Y'all help me. Total from the first hospital. What? 20. 20 total. Total from the second hospital. 30. And then so if that's the case, total. I'm going to write the total. What would be the total doctors? 50. Exactly. Okay? So far, so good. In a way here, I'm saying like the 20 and the 30 will make the 50. Okay? Awesome. Good start. Now, let's do the selected. How many are going to be selected from the first hospital? 8. Very good. I'm going to write selected. Selected. And then how many from the second? Awesome. Ooh, selected. There you go. I managed to get it. 7. So what's the total selected then? The total selected. 15, exactly. Same as the last time. They should add up to make that number right there. So I'm going to put those numbers in. Let's see if it works. And if it does, then we just go to the calculator and get the numeric answer, I guess you can say. Okay. We're going to do the same process a lot. I call it box method. I don't really know. It's like grouping method or something like that. First and second, submit, and we're good. Okay. That is not hard. This one's the not hard question. Okay. If it were just this way, I wouldn't mind. Are y'all feeling what I'm feeling? Okay. So I'm kind of doing like pseudo notes for this guy. All right. Now it's going to say actually find the number, which I just use a calculator. Okay. And I want to show you what that looks like. So let's do, we got Desmos up? Desmos. So I'm just going to put that whole thing in. I was just testing something before class. Okay, so I got a fraction, NCR 28 times NCR 37, and then NCR 5015. And there we go. So what would I actually put in this box? 11%, exactly. I think they want 2 decimal places into the box, so it's technically 4. I know it's really weird. There we go. Cool. So now you're understanding how I'm typing it, right? And we did this last time. I'm just making sure that we're all cool, okay? Any questions on the first and second? If it were only this way, it would be great. But then they're going to do like card flushes and stuff, and we're going to figure it out together. Okay. I'm going to scroll. Here we go. Continue. So, technology companies offering back to school customer specials, 2 different products for this and that. So they're just wanting to know if it's combination or permutation, essentially. Okay, so let me reread it then. Technology companies offering special on its customers. Customers may choose 2 different products out of 8 for a 15% discount. Is order important? No, you're just going to grab 2. You want your markers and you want your crayons. Boom, you're good, right? But if you chose crayons and then markers, it wouldn't matter. That doesn't make sense. So order's not important. It will not matter. And in a way, it's only a true-false question. Because if you chose permutation, you have to say that it will be important, right? And if you say combination, you might as well put that it was not important because these are the same and those are the same. Okay? So this is actually just a 50-50 problem. You have to just click 2 of them. Good? That was easy. Come on, Chad. Why are you making it a big deal? I know, right? Gosh. Now we have to do it. Now we have determined that the problem deals with combinations. See, little C there. How many different ways can you pick 2 products chosen from 8? What's the total? What's the selected? Sounds good to me. You would think that, oh man, Chad made a big hype about it. So I just typed it in. All right, we're great. Again, I just went to the I went to the calculator. That was all. Cool. Easy enough. All right, cool. We're already, look, we're already 50% there. Oh my gosh. Yeah. I told you it wasn't that many. But here's another one. So a child is selecting 4 blocks. We got 3 red, 5 blue, and 2 green. What's the probability of all 3 red blocks plus another block? So they're saying all 3 and then one other one. It could be a blue, it could be a green. Okay? Either way, I don't really care. So I need to set up my boxes just like last time. Here we go. So same style. Is order important? You're just picking up blocks? No. And they even say the C down there, so we're not really worried. Okay, let's start doing the math now. I want to get 2 different classifications. And so I'm going to say red, and I'm going to say not red. So that could be the green and the blue, as long as it's not red. That's the main thing. Okay, so what's my total red? Okay, and how many am I selecting? 3. All 3 of those are selected. So that's in my red box. Okay, cool. What's my total not red? 7, yes. Out of, how many am I going to select? Only the 1. And because I already have those, I should be able to find the answer, the totals, right? So what's my total going to be here? And then I'm going to have a, perfect. Let's put that in. I'm just going to see if it works before we start doing the math for it. Man, tab does not work. I'm just going to tell you right now, tab is not going to work. 10, 4, check it, and we got it. Yes? Well, right now. Always is a tough word in this section. But yes, on this question with the blocks or the hospital doctors. But when it comes to cards, apparently the whole thing's going to be totally different. But we're going to get there. Yay! All right. And I'm going to be just as confused with you when we get there. So we'll do it together. So here we go. NCR 3,3, NCR 7,1, NCR. I'm singing to you guys. Look, and they want fraction action. 1 out of 30. Submit, and we're good. So that was not too bad. Look, way to go! Oh, yes! I feel so accomplished today. Is this okay? All right, last question is it a permutation or combination? Wow, really? So, family card game has 7 players from 48 card deck. How many different ways can a player have 7 cards? So you're holding your cards. Is order important? No, it's just some kind of like you're just holding them, right? As far as I know. So order not important, combination. Combination not important, same thing. We're good. And we're not done. What's my total? 48. What's my selected? There it is. Oh my goodness. 73629 072. As long as you sing it, it's not so bad. It's more peaceful, right? It's like yeah, I know. You can't sing? Yes, you can. It's just kind of keep it quiet for everyone else, you know. And we're done. Are we done? We're not done. No. So it seems like that was great. We did a great job. Oh, thank you guys. Thank you for your applause. They didn't. Oh, there we go. There we go. Yeah. So let's keep going. And again, a lot of these are going to be faster than others. We're selling different fruits and vegetables for smoothies. Oh, stuff you're adding into a smoothie. Is order important? The banana must go first, then strawberries. No, it's getting blended up, right? It's all getting blended up. And then you put 2 numbers in there. Look, watch this. Did I ever show you that button? Instructor cheat. And it didn't, well, it doesn't show, but there's the answer. Yay! We got it right! Y'all don't have that button? I'm sorry. I should. Okay, perfect. Look, was this one of the 4 questions that we had last time? No. Does it look like the other ones? No. A teacher is lining up her class for a picture. Jackson, William, and Rowan are best friends. And if there's 18 people in class, what's the probability of them being first, second, and last? Okay, hold up for a second. Hold up. Okay. I was just trying to delay the inevitable because I really don't want to do this problem. So, yeah. Is order important? Let's start with that. Yes. So I'm definitely going to have some P's and stuff in here, okay? And I'm personally trying to figure out how this used to work. So I'm going to do a P. I don't want that. I want erase. Erase. I want a P. Where's my draw? So I have a P, and I'm going to have another P in the bottom. And I need to find the total and selected and stuff like that. Notice that I have 3 people that I'm actually interested in. So that's going to be a key to this. And then I know I could get the total. Again, if you're wanting probability, then this is going to be selected over total. So I'm looking at like my selected on the top and my total on the bottom. Kind of similar to the top there. So what would be my grand total? Like my total students. What is it? 18, yes. And so then how many are like taking a picture in a way? I know that's kind of weird. Or how many am I caring about in the picture? The 3? That's what I'm thinking too. But now on the top end, I'm like, who am I actually selecting? And so I have only 3 people that I care about, and all 3 of them are going to be in the picture. Let's try it. And again, I don't know if that's going to work. Don't know. So NPR 33 and then NPR 18.3. And so they say a fraction. Okay. I'm totally going to get it wrong. Let's see. Of course. So, like, okay, I get it wrong. What do you do at the house if you don't know what else to do? Crash it. I'm going to submit again and see what they got. And they got something else. Now, they got this weirdness here. I didn't even think about doing factorials. I was doing NPR. Watch this. Watch this. And this is good that we're doing this together. What if I did this? Nope. Was that the same answer? Let's think about how I have my answer. Not theirs, not theirs. I want to have mine. I have NPR 1515, NPR 1818. Okay. So order's important. We got the P's. Got it. I got 18 people total, and then all 18 are going to be in the picture. So that kind of makes sense on the bottom. But where the heck did the 15 come from? Right? Do it again. It's everybody else. And so in a way here, do you remember that one question? It's been a while where we had the people lined up in Walmart. The first person was being helped. The last people is talking to somebody else. And we had 10 people in the middle move around. Those are the only people I really care about. They're saying that Jackson, William, and Rowan are actually fixed in place already. They're not moving. Like, I can draw it out if you want me to. So, you know me and stick figures. So, yeah, let's start doing it. So, we got the first 2, and then we got the one that's last. I'm really only caring about how many then? 15, right? 15 different folks in the middle. Because those are already stuck in place. See? So that's why they're choosing the 1515. Again, if you go back here. So again, let's think about it. I'm moving people around. How many total people are moving around? 15. How many of those 15 people are going to be in the picture? All 15. See how that works? Now, did I know that answer going forward? No. But I can explain it. And that's the problem here, is that I'm going to see this problem again, and then I'm going to have to do it right the next time. Kind of getting what I'm feeling here? Okay. And it's okay to get it wrong. There was only 4 questions on this section. You will eventually see the same thing. You'll literally copy paste and you're done, okay? Eventually. But until then, you're just going to get it wrong. All right. This one seems easier. I got 12 people in a race. Top 3 I care about. What's my total? What's my selected? Easy enough. And so maybe if you keep getting it wrong, you'll get like the easy answers. You know what I mean? Yay! That's a great question. So, I need to stop the recording for just a second here. Okay, and that's what we talk about exams. So, hopefully you didn't hear that. Okay. So now we will try to calculate the probability that all you choose is first, second, third. We know that there are total ways in this. What's the probability? Oh. So this is a part 1, part 2 kind of thing. This is the total ways that we can have people win first, second, and third. And then they're saying how many ways can you put them on a plaque? I think. So I'm gonna I'm gonna try 1 over the 1320. I'm gonna try this. Yes. I mean, all they're saying is that same number, but just put a 1 on the top because there's like one time one race, I guess. One race. So keep cruising. Okay. Perfect. The swimmer problem. All right, here we go, guys. We got to redeem ourselves now. Or, well, I have to. We have 15 total swimmers. Awesome. And they come from 2 different schools. Oh, two come from that high school, that particular high school there. And we want them first and second. What's the probability of this happening? Okay, so this is just like the last problem that we had here. I'm saying that there's two that we know for sure have finished first and second. So then how many are moving around? Yes, 13 are moving around. And how many of those 13 are actually going to be in the swimming competition? All 13. So far so good. Those are the people moving around, right? I've already said that it was going to be the first and second. They're already fixed in place. Okay, but the total though, how many total swimmers do we have? And how many of those are actually swimming? All 15, exactly. I know there's kind of a funny thing there. Simplified fraction. Come on, get it. Come on, get it. No! Dang it. I told you that this section is from the depths. Okay? I told you that. Like you do the same thing as the other problem and you totally get it wrong. Okay, guys, let's see what they got. Okay, what'd you do? What? Right? What's going on? So they have the 13 in this, but then they said times 6. Give me a second here to think about that. 6 is You're right. Yeah, that's exactly right. See, I'm not reading the problem correctly. How many people do we have actually from there? It's right there, 3 different swimmers. And so, yeah, I didn't read that, sorry. We have 3 swimmers. So then we have 3 swimmers. Oh, I know. We need to draw pictures of these swimmers. Let's do pictures. Picture time. And I need to start erasing because we're getting a lot of eerie. Okay, here we go. Clean enough. Okay, great. Okay. So we got 3 swimmers, and they're so happy to be there, right? Yay! And let's call them A, B, and C. So then I want 2 of them to be winning, right? And so I got A and B that win. Yay! I got A and C that win. I get B and C that win. Exactly right, because order is important. BA, CA, CB, how many times that we can have that happen is 6. So we would take the thing that I had, right, the 13 and the 15, just like we had over here, the 13 and the 15, but then I simply say, well, times 6. And there's my answer. From the depths. Okay, guys? One little word. Yeah, go ahead. Actually, it's a good question. Algebra Land says either one's fine. So yeah, the numerator or out in the front, they're both numerator. Actually, it's a great question. So the anything up top and anything on the side are actually all mushed together. They're all numerator. The only thing that's denominator is stuff in the bottom. Okay, good question. Yes. As an example, let's just say I had 2 times 3 over 5. I'm just making something up. But then if I had 2 times 3 over 5, it's the same thing. Cool? Yeah. Oh, you're good? Okay, good. Okay. So, from the depths, I know. Oh, now we have to read and do more math. And oh, man. Okay, we got this. Guys. I'm going to read the whole problem. Horse race, 6 horses. All right, let's go. So, no. Horse races, is order important? Okay, so MPR is what I'm thinking here. I got 6 horses, predicting all 6. Race at random. What's the probability that the first and second horses are correct? They're not saying anything else. So I'm guessing that they're going to do 2, 2. Nah. Remember, it's the ones moving around. 4 and 4, isn't it? Oh, man, who knows? All right, let's do the simplified fraction. Oh, we totally got this. This will totally work, right? You got me? I got one right, guys. So, thank you. I know, right? So, just like last time, we had the 6 horses, but then the first and the second are already set for sure. So, who's moving around? It would be the 4. Okay? We're learning a pattern here. This is a good thing. Blah, blah, yeah. Right. That would be just order important or not important. That's the only thing. Like literally, I would do the same math here. Oh, right. So yes, yes, yes. I'm understanding you now. They didn't say something about another third horse that was supposed to be in the front, I guess. Yeah, that would see. It's that one little question that changes everything all of a sudden. That's why we're doing this together today. Okay, dude, we got it right. I don't know what you're talking about. Blah blah blah. You ever get through this? Blah 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 blah. Okay, here we go. Awesome. Love this question because I don't know what to do. So we got 15 representatives, and we got men and women. Oh, there it is. My two groups, right? Don't I have two different groups here? And so I'm going to do the box method thing that I did last time. Instead of first and second, red, not red, I'm going to do male, female, basically. So I'm trying. Okay, it's so hard. Okay, draw. Okay, so here's my boxes. Let's set up my boxes. So this is going to be men, and this is going to be women. Awesome. Is order important when I'm sending them to a conference? Nope. So C, C, and C. Oh, well, there you go. Ignore this for a second, please. So, I know you're looking like, well, there's only two, Chad. Why you got three? I know. Hold on. So for my men, it says that I have 10 women and 5 men. So I got 10 and I got 5. So far, so good, right? Only 8 representatives will be given a chance. What's the probability of all the representatives will be women? So hold up then. I got 15 total people, right? How many are actually giving a presentation? Total presentations? 8. How many men are giving presentations? How many women are giving presentations? Look right here. Look. It says, what's the problem? Okay. Of all, what does it say right here? All representatives, blah, 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 presentations will be women. You see that? All. So yeah, how many men? 0. How many women? And so what's going to happen is that this guy right here, because he has a 0, he actually basically cancels that and becomes a 1. And that's why you only have the 2 boxes here, okay? So in a way, like, we don't need to talk about men at all because they're not going to be making presentations. I believe that this is how it's going to work. So here we go. Of course, I'm going to get it wrong. No, I'm just joking. This time I might actually get it right. Oh, yes. You ever have like a lag whenever you hit submit and it like lags for a second? It's like a heart attack every time. It's just okay. Are y'all understanding that one? Okay, good, good. Okay. Oh, I actually have to do the math. Thanks. Oh, you know what I'm gonna do? Instructor cheat. Chad, you're so mean. I know. Why is this in the way now? Go away. Okay, whatever. So, why is it not going away? How do you make that thing go away? Okay. Whoa, 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 whoa. Perfect, perfect. So, because I got things wrong, I'm gonna have to do a lot more questions. Right? What question are we on now? Like 6? A flush in poker is when you have all the same cards, same suit of cards. Yeah. And each suit has 13. What's the probability of being dealt 5 cards and it's not a suit of hearts or clubs? Okay. So I'm getting a flush, and I need to start with a total, I think. What's the total cards going on here? 52. How many total cards should be in my hand? Well, I'm looking around. I'm dealt 5 cards. So 5. Okay, that's what I'm guessing so far. Okay. So this one here is going to be the suits, and this one's going to be the cards within the suit. Hopefully this works. 4 different suits in the deck. How many can I actually have, though? It says I'm not able to do hearts or clubs, so how many suits can I actually use, though? 2 different suits, okay? See, I'm selecting 2 different suits out of the 4 suits. But then this one here is going to be within that suit. So I'm going to say we got 13 cards per suit. How many of those 13 cards should I be holding in my hand? 5, all 5, right? Because it's a flush. It has all the same things, so 5. Oh, please. Oh, please work. Oh, gosh darn it. I'm sorry. Whew. I know you're thinking that I need to do the totals and stuff, but this particular question will not want me to do that. Oh, you know what? I have an idea. I'm gonna do a 1. No, no, I don't feel it, bro. I don't feel it. What now? I know, that's what I was thinking too. Okay, I don't know actually. I'm gonna just try this one weird thing. It's not gonna work. What do they have? This is the correct answer. Oh, two. It's 2 and 1. Why not 4 and 2 though? Thank you. You said it. I didn't listen. Thank you. But why would not 4 and 2 have worked? Does that not make sense? I don't know. That's just me. You know what? Mathematically, let's see if they're the same. So NCR 4-2, NCR 2. Oh, hold on. 2-1. No, okay, fine, you win. So yeah, two pairs of suits, and one of them you can use from the depths. Yeah, the 4-2. That's right. You're right. Two different groups. So you got these cards I can have and these I can't. Two different groups. One of those groups I can use because like half the deck kind of thing, right? It's kind of like what it's saying. I'm splitting the deck up into half. I can only have one of those halves. Or is it that I have two suits I can choose from, and one of those suits I must have all of those cards from there? That's okay. Okay, Chad, you're talking too much. But at this point, it's easy. Okay, once I get this part, it's not too bad. NCR 13.5. Are y'all seeing why I was concerned? Like, are you kind of getting my vibe here now? Okay. Because like I sometimes can't understand or describe or blah blah blah. Oh, decimals. Okay, so that's scientific notation. So that's going to be a 0.00990396, but they're only wanting 4 decimals. So if I had a 99, right, wouldn't that round this one up right here to be a 1? Like 10 essentially, 1 0. Okay, yeah, there you go. Okay, cool. Here we go again. I mean, how much is my I got a 69 right now, guys, just cuz I keep getting them wrong. SKIP. So anyways, there's 9 movies on the must-see list. And your probability of guessing the top 2 randomly guessed. Oh, that was it? They don't even tell us to fill in some stuff. Okay. So the top 2 ranked. Oh, it's ranked. Is order important? Okay, so we got P. So we got an MPR and we got an MPR. Okay, let's start with the totals. I like totals. How many total movies we got? How many are on that list? 9, yeah, exactly. Okay. What is the probability if you guess the summer's top 2 movies? So you already got the top 2 in their places, right? So then who's moving around? The other 7. And out of those 7, how many are on the list? 7, yeah. All right, I'm totally going to get it wrong. You ready for this wrong? It's going to say, you're wrong. 2 decimal places. Am I wrong? Totally wrong. Because remember how they can top 2, you can do one or like A or B, B or A. Like, oh. My bad. Yay! I got it. Thank you. Oh man. Okay. Man, they're so mean. Okay. Wow, that did not give me many points. They don't like me anymore. Okay. Track meet. We got athletes competing for long jump. Is order important? Order's not important whenever you're first, second, and third on an event. Okay. Order's important. Order's important. It will matter. Okay, that one's an easy one. Will that give me the 100%? Am I done here? So we got how many total athletes? What's my total? 14. And how many am I caring about? 3. Here we go. NPR 14.3. Okay, cool. So this is why I don't want to do the workbook on this section, because I don't have an answer key. At least this is telling me what to do. I know, I just started right back over. Look, okay, this is the flush card one. We can do this together. I know we can. We got this. Okay, so we got clubs, this and that. What's the probability of being dealt from the same suit? This is the one. This is the one where I got 4-1, because I'm saying one of the suits, of the 4 suits. In that suit, 13 total, I want 5 of those in my hand. And then total, 52 cards, and I'm going to have 5 of those cards in my hand. Here we go. It worked. It finally worked. I got it. I finally got it. But do you see how it didn't restrict us this time? Last time it said, put them in 2 different groups, all that kind of stuff. This one I'm saying I got 4 total suits that I can pick from, and I just need one of those. Okay? I know. And now I have to figure it out. So, instructor cheat. Yay, I got it right, guys. I got it right. You want that button. Okay, popular airline offers 33 destinations for around the world tickets. And you can choose 5 different destinations. The airline will decide the best order. So is order important? I feel like it's going to bite me. Okay. Because it's the airline that's choosing the best order. But then does it matter what you choose? See, and that kind of interesting, isn't it? You say, I want to go to DC and I want to go to Vegas and I want to go. They're like, yeah, whatever, dude. We're going to choose our own way to get there. Keep cruising. Okay, instructor cheat. I'm really good at cheating today. Yay, cheating. Okay. Have you seen this question yet? Have we seen this one yet? I can be here all day long and we'll never get through them all. 3 different friends visit a store. We got 100 people visit that day. What's the probability that their first, 9th, and 90th? I think we've already done this kind of style before, right? So we've fixed the 3 into their positions. How many people can move around? 97. Out of those 97, who came in the store? 97. All right. But total, how, hold on. Order is important because they're actually first, second, and 90th and all that stuff. Okay. How many total people went into the store? And out of those 100, who went into the store? Okay, cool. Fraction action. Oh, my goodness. Hopefully this works. 970200. Oh, no! First 9/90th was the probability, 3 different friends. 97. Do you see what I'm saying? Do you see this? It's from the depths. Why is there a 3 in there? Oh, because again, it's the 3 different friends. They can rearrange themselves. Oh, when do I know that's the thing or not? Okay, so we already talked about this. We got one. He's not happy to be there, and he's kind of meh. So we got A, B, and C. So we can have A, B, C being the 9/90th and first or third or whatever it is. B, A, C, C, A, B, B, A, B, C, A. You know what I mean, right? The way to do this, though, these 3 is the 3 factorial, or 3p3. So that's what they're saying. Again, back to the swimmer problem, essentially. NPR 3, and then if we did times, where's my fraction action? You're not giving me a fraction action for this guy? Ooh, how cruel of you. What if I just said the times 3 factorial times 6? You're so mean. You're so mean. Okay, 6 over 9,70200. Fine. We got it finally. Man, so mean. So Desmos was being mean to me today. I tried to put it all in at once, and they said, no, you have to do it in 2 parts. I'm sorry about this, guys. I really am. This class will really be much more fun after this. Okay? Yeah, exactly. Oh, they're lined up for the picture. We have got this. You're going to help me. We got this, right? NPR lined up for a picture. Who is moving around? 15, 15. Who's total in the picture? 18, 18. And then we can have those friends move in different positions, right? The 6 different ways that they can be in different places. Oh, wait. Fraction. All right, cool. Here we go. What? Are you kidding me again? No. Is it, are they like reverting back into their ways again? Oh, is that what it is? Oh, they say Jackson's first. Okay, so they said specifically this time, rather than the other time, they said as long as they're somewhere in there. I'm trying to hold back my frustrations. I'm trying to. Because I can't read. Apparently, I can't read. Look. Okay, we can do this. We can do this one. Like, we're so close to the end. 75%. Here we go. I'm going crazy. 10 possible digits for different area codes. Is order important when we're talking about area codes? Yeah, like 2-high-4 rather than 2-4-5, right? Totally different. Permutation will matter. All right. Did we get it? Are we done with this problem? Instructor cheat. I'm going to cheat again. We like cheating. It's okay to cheat. Okay, there we go. All right. Well, we still got time in this class. We're going to keep going. I know. You're thinking, how long, Chad? How long should I go? Y'all are all pretty done. You're done with that section already? Yeah. So like, why am I doing this anymore? So let's go back to the workbook and see how mean the workbook is to us. And oh no, where'd the workbook go? Oh yeah, I was writing on it. That's right. Kabloop. No wait, kabloop. And scroll. Whoa. All right, almost there. Okay. Can you help me with the workbook, maybe? It says, find the probability of being dealt 5 diamonds from a standard card deck, including the 2 jokers. With this, what's my total now? 54. In this case, the joker is considered a wild card. It could be representing anything. Okay, so my thoughts on this one is that I have the 3 separate boxes. Again, it says I'm being dealt 5 diamonds. So it's either diamonds or not diamonds. Is order important whenever I'm handing these out? No. C's, right? So how many diamonds, including wild cards, can there be in this deck now? 15, right? Because it's 13 normally, but with the wild cards, it's 15. How many should be in my hand? 5. Okay, so 15, 5. Not diamonds. How many not diamonds do we have? A lot. So let me just make sure here. So 52 minus the 13 is 39, actually, because again, those wild cards represent diamonds in this particular case. How many of the not diamonds am I actually having, though? I have 5 diamonds out of 5 cards. How many are not diamonds? 0. Isn't that weird? Instead of my total here, 54 total cards. Hopefully this works. And I have 5 in my hand. All right, so because this is a 0, we're going to get rid of it entirely, and let's see if this works. I actually have the answer for this one, and it's why you're thinking that, hey, he's actually got something, like one of the answers. I got one of the answers. That little part over there, that 39, will not matter in the end. 54, 5. Is that the answer that I got? Hold on. I gotta look. It is. It is the answer. 0, 0, 0, 9, 4, 9, 5, 6. in case they want a fraction. I guess you could do that. Did you see this one through the umpteen times we did it on the homework? No. Is it in the workbook? Yeah. Should we do it? Meh. A flush. The flush question. Oh, we could do this. So remember what goes in this box. Do you remember? How many different suits do I have? 4. How many suits do I have in my hand? Like when I, one full suit because of the flush thing, right? How many from that suit do we have total? 13. And how many in my hand? 5. How many cards are in this deck? And how many are in my hand? Bam. Answer blah, 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 cheat. So we did that one. Nice. State lottery. I think I have that one somewhere here. And I'm looking at my answers. Let's try it. So, I mean, is this okay what I'm doing right now? I know it's half boring. It's okay. Okay. So, selecting 5 numbers out of 40. I'm going to ask, when we're doing this lottery thing, is order important? You think yes? You think no? I don't know. So, I don't even know what the lottery is, so I'm just going to, talk about it for a second. Maybe y'all know, because I don't do lottery. Don't you just have, 50-something numbers, and you pick one? So, 29 is my grandma's birthday, and my birthday's 13, and then my dog, ate the 5th biscuit. I don't know. So you aren't you picking these 4 or 5 numbers and scanning it in or something? Is that how that works? So if I pick grandma's birthday first and then the dog ate whatever, it doesn't matter if the dog ate whatever and then grandma's birthday? So is order important? You see what I'm saying? So I'm going to say order not important. And therefore, whenever I'm doing all these maths, then I'm going to use a C. So it says, how many ways can these 5 numbers be chosen from the 40? What's my total numbers? And how many am I selecting? There it is. 40, 5. I actually have these correct answers in my book, so yay, we're doing it right. You purchase 1 ticket. What's the probability of winning? Well, again, it's selected over total. How many different tickets did I buy? How many tickets did I select? Out of a bunch, right? 1 ticket out of a lot. But what if I buy 100 different tickets? Wouldn't I have 100 different numbers selected out of a whole bunch? 8008. So these are the answers for this one. I actually have answers for some of them. Apparently they're right. Yay! Sometimes. Whew. So far so good. I'm gonna keep cruising. All right. Contestant with 6 prizes in a bin. There's 13 elephants, flamingos, and bears. What in the heck just happened? Do I have answers for this one? The flamingos and bears. Actually, I have answers, but I scratched through them because they're wrong. I'm not going to do it. And then, suppose a company is hosting a fundraising marathon. Oh my gosh, is this on your homework? Let's just start with that. Is that on your homework? I didn't see it. Let's set that one down. We're done. Yay! Thank you. Yay! All right. Let's not ever do that again. Are y'all okay enough to kind of get through that and be done with that section, and we'll be done? Okay, good. Yay. Now you're already packing up, bro. Does that mean we're done? I did say that I'd be happy if we just got that done, but we haven't even been here an hour yet. Can we start on this next section? This is actually good stuff finally again. Is that cool to start? It's tiny. Okay, so discrete probability distributions, okay? Some of these definitions I have. Oh, yeah. Here we go. So discrete is when it's finite or countable. And then when it's not countable, that's continuous. And we had already seen this a long time ago, but I'm just going to remind you. we're going to be focusing on discrete, which means like whole numbers. And so in a way, we have like an x and say like an f of x. And so over here, 0, 1, 2, 3, 4, 5. And then we have some other kind of things going on. Actually, this would be not f, but p, probability. So we'll have different like numbers over here. Does that make sense what I'm saying? Like these are the discrete numbers, the x's, the scores. So how many people, how many cards, how many dice, how many flamingos, whole numbers of things. So decide whether it's discrete or continuous. Again, this is just a review of what we've already done. So x is the number of quarters in a parking meter. Is this discrete, whole numbers? Or is this like decimals? Quarters, whole numbers or decimals? Whole numbers, discrete. Didn't we already do this a long time ago? Okay, just a reminder. Okay, cool. Height above the ground when you're skydiving. Is it always a whole number or could it be a decimal? It could be a decimal, could be, and therefore continuous. The time you need to take an exam, could it be a decimal? It could be, and so therefore continuous. And then finally, the number of movie tickets. It's a whole number, isn't it? Unless you're like cutting them up and try to like get back in. You ever do that? You take like a movie ticket, you rip it in half, and like somebody's holding it, like, here, I got my ticket, bro. And they're like trying to pull it out, and you're like, no. Just scan it, dude. Just scan it, okay? And then your friend has the other half. So, yeah. Y'all weren't bad like me. And I'm being recorded. I know. It's like the cops are going to come and get me. This YouTube cops. So, blah, blah, blah. This is all whatever. This is a great example of what we're actually doing. Notice again that I was saying the x values over here are whole numbers, okay? That's what the entirety of this idea is. We got whole numbers right here and probabilities right next to them, okay? So, it says, what's the probability of 4? So, I'm looking around here, and this is the whole list of things. What would have to be required to be my total probability of things happening? Take a guess. 1, meaning 100%, right? So I need to get 1 out of all this. But it seems like I'm lacking something, right? And so how can I actually get this amount right here? There it is. Add them up and subtract by 1. So I'm going to like take the 1, I'm going to subtract each one of those from the 1 to get my final answer. They're like, it's going to be like 20 or 19 or something. Let's do some Desmos. I want to clear all because I never want to see that again. So, I mean, I really like statistics, but like that section is just not cool, man. Not cool. Have y'all ever been doing the homework enough that like they literally repeat the same questions? Yeah, and it's like sometimes, and I gotta say, some sections they only have like 4 questions possible, and they'll just repeat them even though you're not like done yet, like because there's just not enough questions. But that one section has like 100 different variations. It's really upsetting. Okay, all right. So are we cool with that? Here, it says now determine if this is actually a good discrete probability distribution. Again, this should total up to a 1, right? Should. But does it? And that's the question here. Does this actually add up to 100%? Oh, there we go. Yeah. So I'd say yes. Yes. These are 2 different examples, by the way. It's like a hard break here. There you go. Okay, so 100% of probability, and we got whole numbers on the left side. Cool? Easy enough. We're going to start using this for like real world stuff real soon. Like right now, we're just kind of starting off with like, what does it look like and what are we doing here? Any questions? Cool. So overtime hours. And notice that could you work like half of an hour of overtime? Technically, could you work like a quarter or like a tenth of an hour of overtime? Sure. but that's not what they're going to put on the clock. Does that make sense? So whenever you've got a clock in, clock out, how many hours did you work? It's going to be a whole number for the billing department, basically, right? That kind of thing. So number of overtime hours worked in 1 week, and we got all these different options here. Construct a construct a distribution. Here we go. 0, 1, 2, 3, 4, 5, 6. So far, so good, right? But I need to find a probability, and that's always selected over total. What would be my total here? What do I do to find my total? I'm going to count them. I need to count all these technically, right? Because here, this is 6 people who got 0 overtime, and then 19, and then 33, and then 54. We're talking like over 100 something people at this company. What I don't know what you're doing over there. Okay, so 6 plus 19 plus 33 plus 54 plus 44 plus 35 plus 18. So I got 209 total people that do or don't get overtime. And so then here I'm going to have the 6 divided by the 209. And then the 19 divided by the 209. 33 divided by 209. Are you kind of feeling what I'm feeling there? Right? Selected over total every time. Here we go. 6 divided by 209. 0.0287. 19 divided by 209. Am I going to do this all the way down? What do you think? Are you going to do this all the way down? Is this on your homework? Not quite. Yeah, it's similar, but I don't think you're going to have to do every single number here. What should the total be when I add these all up? What should I get? 1, meaning again 100%. Yep, good. Good? So, not too bad there. I'm going to just linger for just a whole second there, and... I see. Yeah, we're gonna have to start using some Desmos. I'm sorry, some GeoGebra here in a few minutes. Desmos is fine for little math, but we need to do big math now. Cool? Let's see. So, notice that we got cool formulas here, right? Cool means crazy. So we got some crazy formulas. We did not do any of these formulas back in chapter 2 because we used GeoGebra. And guess what we're going to do this time? GeoGebra, because I don't really care about this stuff. It's really nice, but it just say try to find the mean, that's the average, or the standard deviation. Again, that's all in GeoGebra. So I want to go and find it for this guy right here, right now, using GeoGebra. And this is just a review, okay? So how do I get back to GeoGebra? I'm going to go geogebra.org/classic. And again, there might be a button somewhere. I don't know. I'm just old school, I guess. Spreadsheet. And I want to put these in. I want to put all that stuff in here. Here. 1, 2. Oh, whoa. 2, 8. Whoa. Did you see what they did? That was a cat like getting angry. So I'm putting in all my information here, and this is not. We haven't done this exactly yet, but at the same time we kind of have. We did the weighted mean, and this is exactly the same thing. It's a weighted mean in a way. So, are we okay putting this stuff in? It turns into a decimal, but are you okay? Okay. So then I highlight it all. One variable analysis. And summation x. And we get all our numbers. Just a review. We'll be reviewing a lot more later. This is just a Thursday, you know what I mean? Mean, a 5.8. I have I don't know what my variance is. I do know my standard deviation. Notice that there's standard deviation for population and standard deviation for a sample. But do you think they want infinity for their answer here? Most certainly not. So instead of putting something silly like that, we probably ought to just put the number that we found and the number right there, 3.544. Okay, so not too bad. How then do I find my variance? Do you remember? You're going to square it. You're going to square it. So it looks like 3.544, and then you're going to square it and get your answer. Now you can use GeoGebra. I'm going to use Desmos. It don't really matter, really. Where's my Desmos? Where's my Desmos? There's my Desmos. 3.544. I'm going to square it. There we go. 12.559936. Okay, good enough. Oh, wait. Okay, there we go. Are you understanding what I'm doing here to get to the variance? They're going to ask, and you ignore them, and you do the standard deviation first. Then you can go back and find this guy. We do this every time. This is just how GeoGebra works, and that's how it is. We get over it. Now, does this make sense, though? Like, looking at what we have, would you say that the average is around 5.8? I mean, right here we got some at 1 and 2, and then we got some at 8 and 9. So what would be the middle? 5, right? It's a little bit weightier on this side. As far as standard deviation is concerned, I really can't tell just looking at it, but it seems reasonable because it's kind of small. It's not like 1,000 or something stupid. All right, awesome. We're almost done because y'all are getting bored, and so am I. So, let's just do this last part here, and I'm not going to do any more math. I want to leave this for next time. Expected value is the same as the mean. It literally means the same as the average. So what they're going to do here on this kind of problem, they're going to have part D, and they're going to say expected value. And then you're going to put 5.8 because that was the mean. It's literally the same number. They're gonna do this every single time. You go through and it's like, part D, what's the expected? And you're like, I already got it. And you're done. Cool? So now you know when you do the homework. Any questions? Thank you so much for hanging out with me today. And it's done. It's finally done. Yes!